This video is all about adding and subtracting rational expressions. Recall that rational implies fraction, so it's really adding and subtracting of fractions. Now expressions, pretty soon in the next example we'll see that these fractions will be made out of polynomials. But in this case, I'm just going to start with backtracking to what we used to do with just plain numbers, adding and subtracting fractions. So what do? Well, here we're trying to take 5/12 and we want to subtract 1/30. Well, those pieces are completely different in size, so we need to have a common denominator. Before we do anything. So let's talk about that. What's a common denominator? Well, we need to be able to take 12 and multiply it by something so that we can take 30 and multiply it by something else and 20 to multiply it by something else. And then our denominators will all be the same. So a common denominator is actually a common multiple, but it's the lowest one to make calculations easier. So you'll notice that you can just multiply them all together because a multiple of 12 will be 12 times something. Multiple of 30 will be 30 times something. Same thing. So if we take 12 and multiply it by something so that we can also get 30 and 20 in there, then we can build a lowest common multiple. So rather than trying to guess, we want to look at a process because we're going to be looking at variables very soon, so we want to have a process rather than just, oh yeah, it's 60. So let's take each denominator and factor it completely, meaning factor it into its prime factors. Well, 12 is 3 times 4, which is 3 times 2 times 2. 30 is 3 times 10, which is 3 times 2 times 5. 20 is 2 times 10, which is 2 times 2 times 5. Great. So each of our denominators has been completely factored, and now we want to build a number that's going to contain each one of these, but eliminate any repetition. So if we build a number, we need the 3 times 2 times 2 because we need 12 to be in our number, and this represents 12. 3 times 2 times 2. But we also need the combination of 3 times 2 times 5 to be in there. So I'm going to take 3 times 2 times 5 and I'm going to say, oh, I already have a 3 and I already have a 2, but I don't have a 5, so I'm going to add it. And then we need the 2 times 2 times 5. So I can say, oh, I already have a 2, and it doesn't matter which one I use, and I already have another 2 in there, and I already had a 5 in there, so I didn't even need to add anything. So 2 times 2 times 5 is in there, 3 times 2 times 5 is in there, and 3 times 2 times 2 is in there. So we didn't take any repeats, we just used the numbers we had. And so we've built this number here, and that number is 15 times 4, which is 60. And that's the number you could, it's likely that you could see that 12, 30, and 20 all fit into 60. So pay attention to this process of building a common multiple. Essentially, we said we want to have every one included. So we want to have all of these factors included, all of these included, and all of these included in our common denominator. So now we can look at it and say, well, 12 times what is our 60? Well, 12 was the 3 times 2 times 2, so we need to multiply by the missing factor, which was 5. And then 30 was missing a 2, and 20 was missing a 3. So that leaves us with 25 over 60 minus 2 over 60 plus 9 over 60. And we can just now combine the numerators because we have 25 sixtieths minus 2 sixtieths plus 9 sixtieths, which is 32 sixtieths. And of course, at the end, we always want to simplify. So we look for common factors and we go through the simplifying process. In this case, we could remove a common factor of 2, which will leave us with 16 over 30, and another 2, which will leave us with 8 over 15, and I think that's it. Notice you could have done this as well by factoring and removing any common factors. So let's just practice finding a lowest common denominator. Pretend these are denominators and we need to find the lowest common denominator. So in this first example, we want to have the lowest common denominator of 12 and 18. So you could just see that as 36. But if you really wanted to, you could also see that 12 is 3 times 2 times 2, 18 is 2 times 3 times 3. And so we need to build a number that has 3 times 2 times 2 and 2 times 3 times 3. So that leaves us with 36 as the lowest common multiple of 12 and 18. Now notice we also need to include 5 x's in here. So we need to have 36 x to the 5, and that'll contain this 1, because we can just multiply this one by x to the 4 to get x to the 5. And then y to the 4. So notice for lowest common multiple, you're finding the highest exponents, and if you recall, for the greatest common factor, you were looking for the lowest exponents. Great. Next, we have something we need to factor first. So let's take out the 2y. We're left with y minus 3. And the 5, we're left with y squared minus 9, which then can continue and become 5 times y minus 3, y plus 3. So we need the common denominator for those. Well, we want to have common denominator for 5 and 2, which is 10. We want to include a y, and we want to include a y minus 3. This one's done. So the 5 is in there, the y minus 3 is in there, but we were just missing the y plus 3. So we want to include that as well. So that's our lowest common multiple. And for this last one, the lowest common multiple of 6, 4, and 5, this will be 2 times 3, 2 times 2, and 5. So we need to have a 2 times a 3, and then times a 2, and then times a 5. We also need an x and a y. But before we do the x's and y's, we need to factor these. So this will be 1 minus x. And this one here will be 5y squared. And then this is already factored as, and notice this is x minus 1 to the power of 2. But this here can also become x minus 1. So this is actually, we can factor out a negative and get x minus 1. So because there's this negative here, that negative will just, if this was a fraction, it'll come up front and it'll change the sign of that term. So no worries about that for the lowest common denominator. But what this means for us is we need to have one x, that's the highest exponent on x. We need to have two y's because that's the highest exponent on y. And we need to have two x minus 1's because that's the highest exponent on the x minus 1 term. And so now when we multiply that through, that's 60 xy squared x minus 1 squared. So let's look at a few examples. Here our denominators are already the same. But one thing I want you to be aware of is we need brackets. because otherwise this negative, you might not apply it to both. So remember, the bottom stays the same once it's common, but then the top actually becomes an expression that you need to simplify. So keep the tops in brackets before you expand, because this will be y minus 1, which actually gives us negative 1 over y minus 1. This next one, again, got to factor first. So factor everything. This top can't be factored. This one can. This top could be switched in order, but in this case that's fine. However, the denominator, you'll notice this will become 1 minus x, 1 plus x, and we would likely want to have them all in the same order. So let's rearrange that order. So we'll have, to switch this order, we actually need to factor out a negative. But that negative and this negative will actually become a positive. I'm just keeping this top the way it is because we don't need to cancel it out with anything. And then this other one, obviously, 1 plus x is the same as x plus 1. So that leaves us with actually the same denominator, which is x minus 1, x plus 1. And you can always leave the denominator factored. But we want to simplify the numerator. So we've got 2x minus 3. And then this turned into a plus because of this negative from the bottom. And that's 4 minus x. So let's simplify that. We got 2x minus 3. Because it's a plus, none of the signs will change, so we're going to be able to just combine the like terms. So 2x minus 1x is x. Negative 3 plus 4 is plus 1. And we've got our denominators. But hey, look at this. That's actually the same factor. X plus 1 is removed, so you have 1 over x minus 1. Let's take a look at a bigger example here. Again, you need to factor first. So that's done. This negative, you're treating it as the top. This is x minus 6 times x plus 6. But I'm going to make a point here, because you know you're going to be multiplying more things here. You want to leave yourself quite a bit of room when you're writing it out. So you've got x minus 6, x plus 6, and then plus 5 over x minus 6. Leave yourself lots of room with these questions and keep things in brackets. 2 words of advice. Notice I put the brackets in there. So what's the common denominator? Well, this one has x minus 6, x plus 6. This one has x minus 6, but it's actually missing an x minus 6, x plus 6. And this one's missing an x minus 6. But if you do that to the denominator, you have to do it to the top. So you'll notice that these were actually tacked on so that the denominator would be the same. So now on top, you've got 2 bracket x minus 6 minus bracket x plus 2. If you don't put that bracket there, it'll be not correct. And there's the other top. The bottom is all the same now. So now we just deal with the top. So we've got 2x minus 12 minus x minus 2 plus 5x plus 30. Simplify the numerator, and you'll have 2x minus 1 is 1, plus 5 is 6x, and then you have negative 12 minus 2 is negative 14, and then you have plus 30, and that gives you 16. same denominator. And the last step is to simplify if possible. So let's just remove this common factor of 2 here, and we're left with 3x plus 8 over x plus 6, x minus 6. And that's all we can do. Nothing cancels out there.